predicting spontaneity. Standard cell potential, okay, for a reaction, for a redox reaction, you can look at the standard reduction potential and the standard oxidation potential. If you add those two up, you get what's called the standard cell potential, okay? Now, this is really the negative of the reduction potential that you look up, right? Because you have the numbers that you have to look up would be reduction potentials, okay? So keep in mind that when you say plus here, okay, we're assuming that we're flipping what we look up, okay? If you don't flip what you look up, then you subtract, okay? So under standard conditions, the standard cell potential for a spontaneous reaction is positive. So a standard condition simply means that all the reactants and products are present and have activities equal to 1. Okay, so that means your reaction quotient in a standard, under standard condition is 1. Okay, when all the activities are 1. So let's take a look at this one. Is the following reaction spontaneous under standard conditions or not? What are the half reactions here? The copper ends up being copper solid. Copper ions end up being copper solid. Your standard, this is oxidation or reduction? Electrons on the left. That's reduction, right? Right? Now, what do I do for silver to silver plus? What's my standard? So my reduction potential here is plus 0.34 volts. That's what happens to my copper. What happened to my silver? It's oxidation, right? What's my oxidation potential? Is it 0.8 or negative 0.8? Look at this expression right here. That's also reduction, right? So if I flip it, I make it oxidation. Look, I actually flipped it. My silver solid is on the left side of my actual reaction here, my given reaction. So my standard oxidation potential would be negative 8.800 volts. So what's my total standard cell potential then? What is positive 0.34 plus negative 0.8? 0.34 minus 0.8 is negative 0.46. What does that tell me? This reaction, as written, is not going to be spontaneous. It's not going to occur. Okay, this is a non-spontaneous reaction. Okay, in other words, if I were to put silver metal in a solution that has copper ions, I'm not going to get copper metal and have my silver metal dissolve in it under standard conditions. Okay, but what if I flip this reaction? If I write it the other way, if I have instead copper and I put it in a solution of silver ions, will it give me copper ions plus silver metal? What's my standard cell potential for this? You're going to have to flip all your numbers, right? So now this is going to be equal to positive 0.46 volts. So this means that if I have copper, okay, I put it in silver, in a solution that has silver ions, I can generate silver metal out of that mixture under standard conditions. Okay, so that would be a spontaneous reaction. Now, what I can do is I can carry out these two reactions in separate compartments so that I can allow the electrons to travel through a wire. And what I've made is called a galvanic cell, or in everyday language, a battery.